In this slide, we are using the so-called um, space filling model. So that is showing the size of the living group and the size of the substituents that we have attached to the carbon atom that is going to be attacked by the nucleophile. So if you have a CH3, well, the hydrogen atoms are fairly small, and that's why the approach of the nucleophile will not be so difficult, right? It will not be so difficult to approach that carbon atom. You can see still some black portion there. But if you substitute, you replace one of the hydrogen atoms with a methyl group, so then now the approach will be a little more difficult. It will not be so easy. So here we have a methyl halide, and here we have a primary halide. The primary, you should expect that the reaction will be a little slower. How about if we put two methyl groups? Well, two methyl groups, now the approach is definitely more and more difficult. And if you have three of them, you cannot even see the central carbon atom that is supposed to be attacked by the nucleophile. Okay, so that is that slide. And then here we have now the order of reactivity in an SN2 reaction. So as we were discussing just now, the methyl halide will be the most reactive, the methyl halide, and the least reactive of all will be the tertiary halide. But here, McMurray is giving you some numbers, right? So 2,400,000, 501, etc. So I suggest that you think of those numbers in terms of time. Let's say that this reaction here with the secondary halide, the 2-bromopropane, let's say that the reaction takes place in 1 hour, just to compare, right? Because they are telling me that the relative reactivity of this is 500 is to 2 million, so that means that the reaction with a methyl bromide, it will be 2000 divided by 500 times faster. And when I calculated that, that gives me that if the reaction with the secondary halide took 1 hour, so the reaction with the methyl bromide, it should take less than 1 second. So it's almost an explosive reaction, right? So fast. So most likely it will be necessary to slow down the reaction somehow. How can you slow down the reaction? Well, one thing that you can do, you can run the reaction at lower temperature. That will be one reasonable trick. In the meantime, when you run the reaction with the so-called neopentyl bromide, neopentyl bromide is technically a primary bromide, right? Because I have the carbon atom to which the halide is attached to only one other carbon atom. Yeah, but it's a very, very bulky thing, right? So, and the relative reactivity of that is 1. So what will be the reaction with the neopentyl bromide if with the secondary it took 1 hour? So I calculated that the rate of that reaction should be such that in order to get formation of the same amount of product, I will need to wait more than 20 days. So for all practical purposes, we will say, no, that reaction is not practical. You know, it's not, you cannot use those conditions of reaction. How can you speed up the reaction? Well, one way to speed up the reaction will be to run the reaction at a higher temperature, or yet another trick, it will be to use different solvents. Some solvent that will facilitate an SN2 reaction to go faster. Okay, I will stop here and we continue.